tangent of theta. Well, what's tangent of theta? Tangent is really just what over what?
Y over x.
Y over x. Okay. Well, if that's all it is, then here's my y, here's my x. I don't even know what my y is until I do something. What do I have to do? Pythagorean theorem. Okay. So Pythagorean theorem says
1 squared minus 2x.
hypotenuse squared equals 2x squared plus what?
B.
B, call it B, squared. Well, that's 1 equals 4x squared. Right? Now what?
Then you remove 4x squared.
Yep, move it over. Okay, 1 minus 4x squared equals B squared.
Square root it.
B equals this. Square root of 1 taking away 4x squared. Is anybody tempted to say 1 minus 2x? You're not even tempted to say it? You are?
Yeah.
Yeah, because you're thinking, I know the square root of 1, I know the square root of this, 1 minus 2x. Problem is you can't do that because it's what? It's subtraction. You can only take the square root if it was something like,
Multiplication.
yeah, like let's just, I'll try to change the numbers on you. Like if I did this to you, now can you do it?
Yeah.
Yes, that's 2 times what?
3.
3x, which makes,
6x.
yeah, the answer would be now 6x. But because you have a minus sign or a plus sign, you can't do it. You're just done. That's it. Okay, so that number, that funny looking number is right here. So now you're supposed to answer this question. What's tangent of theta? Theta's right there. What's the y?
Square root of 1 minus 4x squared.
Yep. And then what's x? 2x. It's a very abstract answer. It's not like you're, 1 over 5 or 2 over 3 or root 2 over 2. It's not a number. It's an algebraic expression. You guys were given an algebraic ratio, you're probably going to get an algebraic expression in the end. And it's pretty ugly. Okay? Seems incomplete, like I should keep going. I get that. But I'm not telling you what x is. If I don't tell you what x is, you're stuck. You're just done. Yay, nay, don't get it, yeah.
Could you cross out the x's?
But see, here's the problem. It's not x. That's not, I know what you're saying. X squared over x cancels with one of them, and it's just x. If it's not the square root of x. This is the square root of x squared. You can't do it. I know how tempting that is, but no, can't do it. Yes, no? Okay. Tangent of 5. No calculus. What is it?
5.
Okay. So you say, boom, boom. Inverse operations answers what? 5. Is he right?
Yeah.
Yes. I was
Here's the deal. You're not right. But I get why you did that because they're inverse operations, right, guys? Okay, why is he not right? Do you know, Serena? The inverse was restricted for sine, tangent, and cosine. Do you guys remember that? Oh, say that again. What did you say? Yeah, okay, so she said the inverse is on the outside. So what this does, this is tangent of an angle. So you're going to get a ratio, correct, guys? Okay, but inverse tangent of a ratio, you have to remember that tangent was restricted, wasn't it? From here to here for positives, right? And from here to here for what? Negatives, right? Well, my question is, where's 5?
On that side.
On what side?
The right side.
Is this 5 degrees or 5 radians? Yeah, so 5 radians is really, when you think about it, I mean, this is how far right here?
Pi radians.
3.14 radians. 5, if you go to 270, you know your hat? No. 6.28 way over here. I'm saying right there. You get to this spot. It's actually, it's 1.57 there. So if you add that on, you're going to end up with like 4.71. So where's 5?
It's on the other side.
It's right here. Yeah, it's right there. Okay, so here's the deal. The answer is 5. If you set it that way, it's 5. I get it. But the problem is you're restricted. You have to stop here. You can't say anything over pi over 2. And if it's in this zone, you got to say negative what? Pi over 2. You have to give me the answer in the domain. So like, how far is, this is really the answer right here. The answer is this way.
So it's -1.
Well, it's not -1.
We have to switch it to degrees.
No, you don't have to switch in degrees.
Negative pi over 6? No,
Well, listen to this. How far is it from here to here?
that's 2 pi.
That's 2 pi. And you know the answer's this way, but you know this is what? 5 radians. So what's this?
1 radian.
You use minus 6,
Say it again.
minus 2 pi minus 5.
Yeah. Watch my hand. How far is this? 2 pi. Now I want this, but I know this is 5. So if I took 2 pi and I subtract off the 5, I'm going to get that distance, right? So really, the answer is 2 pi, take away what? 5. And you're going to get roughly,
Would be negative 1.2.
it's going to be it's 1.28, but you have to realize you're going which direction? Negative. So why is this problem hard? I mean, Howard just said 5, and Howard, you're right. The answer is 5. But Howard gave me the wrong measurement. He knows the answer's here. He went this way, 5 radians. But the restriction says you can only say 0 to negative 90. So you got to give me this answer. Do you realize this answer and 5, they end up in the same spot? You get it? Yeah, one goes the positive direction, one goes the negative, and your restriction says if your ratio is positive, you're up here, 0 to pi over 2, and then 0 to what? Negative pi over 2. That's the one they want. Careful on that one. It's going to happen in your assignment maybe once. But then you're going to go, why am I wrong? And then you got to think back what I just said. Okay. Without a calculator, try it. You guys realize that just means arc secant, right? I mean, arc secant is inverse secant. Are you guys working with secant? Is anybody changing it? Emma, what'd you change it to?
Cosine?
Okay, so Emma goes like this. I don't like secant. I'll just do the inverse cosine instead. And that's what I would do too, by the way. Yes?
Shouldn't the equation from the top be 2 square root 3 over 3 instead of 2 square root of 3?
Oh, yeah, I suppose it could be, yeah. But, I mean, this is what they're telling me. Inverse secant of 2 over this. But what I'm trying to tell you guys is no matter what you do, I wouldn't work with secant. I'd go straight back to cosine. But here's the problem. Because I switched to cosine, what about the ratio?
Flips.
Yeah, you got to flip it. You got to flip the ratio. So make sure you take, if you're going to switch the trig function, make sure you flip it. And now this is what I'm asking you. Remember, if I give you inverse cosine, it's a ratio. I want an angle. Play with those special triangles and get the right one. Is it 45, 30, 60? Is it a quadrantal, 0, pi? What did you guys pick?
30 degrees.
You want 30? Okay, let me check it out. Here's 30, here's 60, here's 90. Okay, so this is a 1, this is a square root of 3, this is a 2. I heard you guys say what? 30. Oh, let's check it out. This is cosine. Cosine is x over r. So, well, I didn't draw my triangle right because I didn't put it on the xy axis. Let's just figure this out. Cosine is adjacent over what? Hypotenuse. You said 30. Adjacent to that would be this and this, correct? So is it this? Is it 30? Yes. Yeah, Emma.
Why is inverse secant equal to, or like cosine, or inverse cosine? Isn't inverse secant just cosine?
No.
Because cosine is secant, right?
Cosine and secant are inverses of each other. So like if I told you, okay, if I go like this, cosine of 30 degrees and secant of 30 degrees, cosine of 30 is what? This over that, square root of 3 over 2, right? Where secant would be the reciprocal, it'd be what? 2 over square root of 3. I know they didn't rationalize that, guys. I understand that. But these ratios are inverses of each other. They're reciprocals. So what I'm saying to you is just, I think secant gets confusing. I think cosecant gets confusing. Just change it to cosine. But then you can't forget to do what? Yeah, the ratio gets flipped. If you're going to use the reciprocal function, you got to flip the ratio. Or else you're going to get it wrong. Okay? There's another answer here. If they said give me radians, you'd say what? Pi over 6. Yep. Okay. So that could be the other answer. Somebody in period 5 said, how do I know which one to give you? All I'm going to say to you is this. Read the directions. See what it says. If it says give me theta between 0 and pi, I want radians. 0 and 180, I want degrees. But if they don't say anything, what can you do? Choose. Yeah. Okay. Okay, try this one. Do you guys already see all this?
Yeah.
Oh, good. Oh, that's disappeared on me. Okay, come back. There we go. Okay, try that one. Cotangent. Inverse cotangent of -1. You don't have to work with cotangent, do you? You could just do what? You could just do tangent, right? Inverse tangent of, flip the ratio. When you flip -1, what happens? Yeah, so this one actually doesn't matter what you do. I mean, I just like to see tangent. Okay, this is what? -1 over 1, right? And now I got to start thinking, okay, what triangle is this again? Well, 1, 1. I'm gonna try this, right? I'm gonna try my 45. Okay, tangent is opposite. That's opposite over adjacent. 1 over 1. Thumbs up. I got it. It's 45. Problem is, it's a negative ratio. So you are restricted with inverse tangent, cosine. All of them are restricted. You have to do what? All positive up here, all negative down here for sine. This is inverse sine and tangent. You have a negative ratio. You're going to be where?
-4.
You're at negative 45. So your answer is negative 45 or negative pi over 4. Yes? If you said pi over 4, you're telling me this angle right here creates a -1. It does not, right? This is 1, this is 1. 45 creates what? 1 over 1. And I have -1 over 1. So you have to tell me down in this quadrant. Can you tell me this? Is this okay? Can you tell me the answer is 315 degrees?
No.
No. You went past
The restriction.
the restriction. You went into the forbidden zone. You can't be over here. Okay? Good? All right, try these. Use a calculator. Go ahead, use them. Hello? Good luck finding the cosecant button. I'll think you can. You got it, Zach?
No, I don't. I was asking.
I think. No, you're right. First, I take 1 over inverse sine of 2. That ratio is because that says to me that the number on top is your opposite side of the number. You're laying everything on.
So now I'm gonna do 1 over 2.
Yes, that would work. I wouldn't do it that way either. I'll show you what I'll do.
Oh.
Okay, you guys, did you like this, working with cosecant? Probably not. Changed it to what, I hope? Sine, right? Okay, you guys, do you understand? That is a ratio. It's 2.1 over 1. You just have to do what? Flip it. That's all I gotta do. Punch it in. Help. Sorry, what? 2844. Okay. What if I said on the test? I want radians. 0.496. How'd you do that, Chris? Did you do this? I'm just curious. Did you go like this? Is that what you did to get that?
No, I just originally had mine.
Ah, got it.
It put out on me.
I know it did. That's not good. I don't know if I'm going to be able to record this one.
Run out of storage.
No, the
No,
smart
it just
program
kinda
is
quit.
Oh.
It's still recording.
I know
so.
I know. So maybe we'll get lucky. Okay. All right. Now let's go here. Here.
Next
We
one.
did that.
So it doesn't remember
Okay.
doing
That's
it.
okay though, right? Because they should still see that. Okay. So here we are. Anyways, this one I would do what?
Make it sine. Inverse sine.
Yes, inverse sine of, and I would remember that that's a ratio, flip it, 1 over 2.1. Now I got another ratio, punch it in, 2844 you said, right guys? Okay, then I asked Chris, I said, Chris, how'd you change it to radians? Did you do this, times 0.5 over 180, and you said what to me?
If we can do that, but I just originally had mine rated from last time.
So you just said, I'll do it again, but make sure my calculator's in radians to get the 0.4 what?
0.496.
So it doesn't matter. You can take it times pi over 180 and get this, or you can just go back to radians in your calculator, type it back in, and you'll get this.
Or your calculator's already in that. You didn't change it.
Well, yeah, I don't know what your calculator's in.
I don't
Okay.
use it.
What about this one? Arcsecant. Cosine of 4/5. Okay. Sorry, I was thinking of the other problem for a second there. Okay, so yeah, you've got a positive ratio, right? So you should be up in here, correct? Not in here. So type that in, see what you get. Help me. 3687. So roughly here, 3687 degrees in radians. 0.644. 644 radians. Good? Not too difficult, is it? No. Especially when you have to use your calculator. Looks like that's it, right?
Yep.
Okay. Okay. Take the next slide. It's blank, isn't it? Okay. Did not do very well on this. I'm talking last week's quiz. All right. So here you are at Valley Fair. You're on that famous Ferris wheel. You're sitting right there. This is where you're at. Okay? That's you. And you are gonna go how far around the circle? I'm gonna stop you right there. I'm gonna say you went 3/4 of the way around the circle. You did it. Oh wait. I'm gonna give you this. This is your radius, 30 feet. But you did this in 30 seconds. Okay? Now, we did not do very well on our quiz. Angular speed knocked you guys down, punched you, and knocked you up. Not all of you, some of you. Anyways, will you give me the angular speed of how fast you're traveling in radius? Go. Just so you know, your answer sounds something like this. I'm traveling at pi over 6 per second. Something like that. That's what it should sound like. We finished the notes. Now I'm just hitting problems from last week. Did you go well with this? So here's your notes. She's just trying to do this. Once we get angular speed, we're going after this one, guys. V for what? Linear speed. Okay, angular speed was what divided by what?
Theta over time.
Theta divided by time. Theta must be measured in radians. Okay, don't tell me degrees because I don't care about degrees. It's radians. Now, from there to there is how many radians? Okay, no one's talking. All right, fine. From here to here is how far? Right here. Just to there. Half a circle. That's pi. This is half a pi. Okay, guys, we're going 3/4 the way around. 3 pi over 2. Guys, I said 3/4 of a circle, which messed you up because you were thinking, oh, it must be 3/4 pi. No. Half a circle is pi, and another quarter would be a half, so pi plus a half is 3 halves. So you have traveled what? 3 halves pi, and you did it in how many seconds? 30 seconds. But I want per second. Like how in 1 second, how far are you going? Well, take your 3 halves pi, right? And multiply by the reciprocal. Don't divide by 30, multiply by reciprocal. 1 over 30. Well, anything canceling? Like I'm thinking 3 and a 30. 3 goes in 3 once, 3 goes in here, 10. Wouldn't the answer be what? Yeah. Why did I put 3 theta?
I don't know.
Oh, that's weird. Okay, you guys didn't even say anything. 3 pi. Okay, anyways, it's pi over what? 20. Per second. There we go. That's how fast you're traveling. Pi over 20 per second. Now, pi over 20. What's pi over 20? Is it this much? Is it this much? Is it this much?
Like that much.
Well, first of all, pi is 180. It's 9 degrees. It's 180 divided by 20. It's 9. So does this seem like you're going really fast? 9 degrees would probably be in 1 second. Does that seem like you're going really fast? No. That's probably realistic. Okay, come on over. Let's do this one. Linear speed. Linear would be like miles per hour, feet per second, like that kind of stuff, okay? So how do you get it?
Radius times angular speed.
I heard you say arc length, didn't you? Over time. That is true. It is arc. But I gotta tell you something. You picked the hardest. Because what is this? What is arc length? It's what? Exactly. But now I'm going to ask you this. Ready? What's this?
Radius.
Theta divided by time. Theta divided by time is what?
Angular speed.
Angular speed. So really, can't the formula just be this every time, guys? Radius times what?
Angular speed.
Angular speed, which you already know because you already did it. It's right there. Yeah?
Hey,
You guys are making it hard when you do this. It is arc length divided by time. It is. Then you do this, divided by this, when really you could just do that and be done. And guys, do you know the radius?
30.
30, yep. 30 feet times, do you know your angular speed? Yeah, it's right there. Pi over what? Per
Second.
second. So here comes your answer in feet per second, right?
4.7.
You know what I'm going to do? You're right, it is 4.7, but I'm going to go 20. 10 goes in here what?
Twice.
Twice. 10 goes in here 3. So it's really 3 pi over what? 3 pi over 2 feet per what? Second. And the only problem with that answer, I really don't know how fast you're going. I have no idea. So you type it in. 3 times pi divided by 2.
About 4.7.
About 4.7 feet per second.
Yeah.
Does that make sense?
That's not very fast.
It's about this fast. 1001. Is that fast? 1001. That's about 4.7 feet. That doesn't seem too fast, does it? Okay. Do you get it? So really, it's not that hard, is it? And half the class got it wrong. Just so you know. Okay, what else did you guys get wrong on the quiz? This one. The unit what? Circle. Look at this. What about the unit circle? What's the radius?
1.
It's always 1. Okay, this would be, that distance would be what? X. That distance would be y, which would create this point on the circle, right? X comma y. Okay, the reason I left that blank is because I want to show you something. Do you guys remember that I did this with you and I said, what's cosine of theta? Cosine of theta is really just x over 1. Oh, it's just x. What's sine of theta? Y over 1. Just it's just y. So that means if you want a point on your unit circle, all you got to do to get x is what? Yeah, guys, it says here x equals cosine of theta. If you want the y value, just do what? Sine of theta. You okay with that? That's all you got to do. And then I told you right after that, I said, you know what I don't do? I don't use the 1. If somebody tells me this works on the unit circle, I'll use any triangle I want. I'll use my numbers. Okay? Now this is what you guys got. You guys got this on your test, your quiz. You got this one. What's the ordered pair right there? Well, when theta is 3/4 pi. What's 3/4 pi?
135.
It is 135, which means your reference angle is what?
45.
Yeah, it's a 45. 1, square root of 2. This is a negative, correct? And do you know what you guys told me on the quiz? You said this was the answer. Oh, x is -1. Y is positive. You told me -1, 1. That's what you said the answer was. Nope, it's not that. It's going to be this. It's cosine of theta and sine of theta. So what's cosine of this number, or this angle?
Negative square root of 2 over 2.
Yeah, well, first of all, you got to look at the reference. It's going to be this one over this. So it is going to be,
Square root of 2 over 2.
it's negative root 2 over 2. And then what's sine of 3/4?
Positive root 2 over 2.
Yep. So these answers aren't even close. I mean, yeah? Okay. There's one I want to do with you on your packet, so we'll do that in a second. I think that's about it. You guys, why didn't you get A's on your non-calculator? That one, you lost 2 points. The angular speed, the linear speed, you lost 2 points. Now you're up to 4. It was out of 35. You are not going to get an A if you miss 4 points. You just won't. So a lot of you probably could have had a whatever grade you got, lifted up one letter grade. You could have got a better, obviously better. But it just didn't happen. And there was the problem. Okay, I got 2 of these. I know your assignment's to finish 4-7, but I got 2 of these, and I'd like to give them to you. And I'd like to work on a few of these right now with you. So come up and grab 2 of these, will you? If you have to grab 3 of them, grab 3 for your partners. You just got in right now?
A little bit. You should grab you. I appreciate it.
Oh, because it's a stretch.
This stuff is due Thursday. Just so you know, this was repackaged. Thursday. But the sooner you get it going, the better off you're going to be. Don't wait. Okay, now, can you pick the smaller packet? It's I think there's 4 slides. Pick the one that has 4 slides. Okay. Here we go, guys. It's this one. Second box down, very first problem. When you do that one, it says, find the point on the unit circle that would correspond to the rotation of 7 pi over 6. I just showed you what to do. Let's see if you listened or understood it. It's right here. I'm asking you to do this kind of problem. Second box, down here, the very first problem. What was X again? On the unit circle, how do you get X? Cosine of theta. And how do you get Y? Sine of theta. And by the way, theta's right here. Where is 7, 6, pi?
All the way around.
It's how far?
31.
Just past all
3 degrees past this.
It's isn't it 210? 210 degrees, right. So you're right here on the circle, and this creates what triangle? Reference angle of 60, okay. And this is going to be 2. This would be -1. This would be, okay. So what's the ordered pair? The ordered pair, now here's what some of you said. You guys went, oh, it's got to be left -√3 and down -1, and that is not correct. You can't do that. In the unit circle, it's always going to be what?
the radius.
Cosine of 7, 6 pi. Sine of 7, 6 pi. 7, 6 pi. Okay, what is cosine? This or that? Yeah? What is sine of 7, 6 pi? Yeah, -1/2. That's how it is. There's no reason to get these wrong. And guess what? I'm not using 1. I chose not to use 1 because any triangle would work. I could put a 6 there. I could put a 12 there. No matter what, the ratios are always going to come up to be these 2 ratios. Okay? Go to the next one down. Talks about angular speed and linear speed. There's a horse on a carousel. So you're on a little merry-go-round and a carousel. You're at Valley Fair again. You make how far'd you go? One revolution, which means one circle?
Yeah.
How far is that? That is 2 pi radians over 12 seconds go by, right? Wow, reduce it. You're moving at what angular speed? Per? Pi over 6. What's pi over 6? Oh, 30 degrees. That means every second you've gone about how far? 30 degrees around the circle every second. That's what that means. Okay, that is angular speed. You didn't do well on the quiz. Did you get it? It isn't hard. You just gotta know how far did I go? One revolution, 2 pi per 12 seconds. Okay, divide by 12, you get it. What about this linear speed at v? What formula did you go with? Yeah, I think you guys, if you catch on to what I just said, it is r times omega. Omega is your angular speed. What's your radius? 12 feet. 12 feet times, what over there? Pi over 6 per second. The unit is already there. Feet per what? You're in feet per second right now. You just have to multiply that number, 12 times pi over 6, and get what? 2 pi. Hey, what speed are you guys traveling at? 2 pi feet per second? Yeah. See, it doesn't mean much to you guys, 2 pi. I mean, you should probably, to make more sense, you're traveling at what? Yeah? That's all that is. Okay? I'm sorry, I wish that wasn't so hard last week, but I think if you see it again and again, it's going to get easier and easier for you. All right. Would you look at number 1 and 2 on the top? This is on Wednesday's test. I'm trying to get Wednesday's test questions in right now. You just did angular speed, linear speed. You did point on a unit circle. The top says to graph a sine cosine. Is there one that looks harder for you, or do you not care? Should we try one? Yeah, but which one? Which one? 2? 2 looks harder than 1. Okay, everybody go do. Let's do 2. And I see my time is getting close to the end, but I think we'll get far enough. Find this right away. Your period. Find the interval, right? Find where you start. And find where you end. That's huge. There's 2 more things to find, and they are amplitude. And then, I think I said 5. This is 6. 5 was, does it go up? Is there a shift up or down going on? Okay. Yeah, but these are the questions, right? Okay. So what's your B value? It is 1/2. What's 2 pi over 1/2? 4 pi. So every 4 pi, the wave completes itself. Okay. Divide by what here to get the interval? Take your period, 4 pi, and divide by 4. Oh, pretty sweet. I get to count by pi's. 1 pi, 2 pi, 3 pi, 4 pi. Okay, where do I start? Don't you always want to put what number in first? Sign of 0? Well, if you want to put sign of 0 in, when is that junk in there? 1/2 x minus pi over 2. When is it 0? Well, move this over, get 1/2 x equals pi over 2, right? Then what? Multiply by 2 and get what? Pi. Oh, guess where I get to start? At pi. I start at pi, and then where do I end? You end at 2 pi, so set it equal again to what? Set it equal to 2 pi. Because you know your sine period, sine has a period of 2 pi. So that's the end of it. Set it equal. Guys, do you realize you only have to do what? You could take your starting point and add what? You could add your period to it, right? What's a 1 pi plus a 4 pi? You're going to end at 4 pi pi. I don't want to do the work. You start there, you finish there, right? All right. Finally, you said no to this, didn't you? There's no up-down movement going on. Okay, what about your amplitude? Always positive 4, which means on the midline, you go up 4 to get the peak, and down 4 to get the minimum. All right, I got lots of information up here. Where am I starting?
2
Nope, start at pi. And then count by what? Pi, 2 pi, 3 pi, 4 pi. This is where I end, 5 pi. Okay, that's 4 equal intervals. 1, 2, 3, 4. Okay, where does sine start? On the midline or at the max? Where? Ah, shoot. Okay, just a quick question. Where am I going to go right after this?
Minimum.
Why?
Because it's a negative one.
Because it's a reflection over the x-axis. Guys, this one goes to the minimum right away. And the minimum is?
Negative 4.
Yeah. I'll come back tomorrow and we can talk about this. But I think you probably get it, I hope.
I just thought.